Alright, now we're going to look at a third new type of equation in R2, what we call symmetric equations. So you're going to see that it's very closely related to a vector equation. So let's say this is our vector equation. So then our parametric equations would be x plus 2t y equals 3 plus 4t. So we saw that sometimes it's kind of annoying to have this extra variable t. When you're solving equations, it can create more work, sort of that in-between step. So what might be useful is to get rid of this t. So can we get rid of the t? And the answer is yes. The way we would get rid of t is to solve for t on both equations. So if I just rearrange this, x minus 1 equals 2t, so t is equal to x minus 1 over 2, and then over here, y minus 3 equals 4t, so t is equal to y minus 3 over 4. Okay. So these things are both equal to t, but t must be the same. So let's equate these. So x minus 1 over 2 equals y minus 3 over 4. Okay. Now the question is, where do these numbers come from? Well, the 2 and the 4, that's just the direction vector. Where did we get the 1 and the 3 from? Well, that's just the position, the point. So symmetric equations, let me not write it like that. So if, let's say, A1, A2 is a point on line, and M1, M2 is direction vector, then the symmetric equation is, so we saw was x minus something over something was equal to y minus something over something. Remember, where did we get the 1 and the 3 from? That just came from the point. So it's going to be x minus a1, y minus a2 over the direction vector, which is m1 and m2. Okay. So there's your symmetric equation. So let's just do a quick example. Let's say you have this is your vector equation, and then you want to get the symmetric equations. Very simple. Just x over equals y over, so x minus your position vector, so x minus the x coordinate, and then y minus the y coordinate, so minus 2, and then that's all over the position vector, so the x coordinate goes over the x part, and the y coordinate goes over the y part, so x minus 1 over minus 3 equals y plus 2 over 4, and that's how we'd leave it. So notice, this gives you the same information as the vector equation, right? It gives you the point, we can see the point, we know it's right there, and we know the direction vector is right there. You might say, should I clean this up? Like, should I get rid of the negative on the bottom? No, generally you wouldn't. So you're going to leave it exactly like this. And now answering questions like, is the point, like, I don't know, 1, 3 on line. It's a little bit easier, right? You can just sub that directly into this. So your left side would be x minus 1 over negative 3. So if I sub in 1, 1 minus 1 over negative 3, I'll get 0. And then my right side would be y plus 2 over 4, and if I sub in 3, I get 3 plus 2 over 4. So therefore, left side does not equal right side, therefore point not on line. So it's a little bit easier than with the vector equation. So that's the advantage to the symmetric equations. Calculations tend to be a little bit shorter.